We wanted to do with the panel today is that we wanted to bring some of our speakers back and then to have a more in-depth discussion in terms of the use of AI. Now, one of the challenges here, as amongst a couple of challenges that we always have, is of course we're virtual, and so we are going to do our best to try and have an engaging conversation, even with you in the audience there with Roman in South Africa. But then also with Sachin, who's on the road and traveling throughout Norway today. So it's good to have him back. He was kind enough and generous enough to come back and join us because Sachin is really the technical expert when it comes to AI and is leading AI's developments in Norway. So this is something that we wanted to dive a little bit further into because, as you've noticed, we're very compressed in time in terms of the presentations that we have because we want to cover a wide range of topics. But specifically for today, we wanted to dive a little bit deeper and then try and see if we can't get some interaction in between what we're talking about, what we're going to brief and sort of introduce very quickly this morning, and then of course into discussion and questions and other feedback from the audience. So just to kick off on the role of artificial intelligence in emergency and disaster management has evolved significantly. I think we've started to see that influencing various facets of crisis response strategies. And as we explore this technological progression, it's vital to consider that both the opportunities and challenges ahead. The use of AI is not without risk. And so we're going to talk about that a little bit more in depth today and this morning over the next 90 minutes or so. And AI offers tangible benefits in disaster management, enhancing early warning systems, and optimizing resource allocation. The utilization of machine learning and data analysis stands as really a beacon of innovation and how we can really accelerate the work that we're doing, promising a proactive approach to managing emergencies, at least in the support function. Additionally, AI's role in leveraging social media platforms for data collection showcases its potential in fostering response and also towards building more resilient societies as just one example of saying using real-time data analysis. However, the journey is not without notable challenges, including data privacy and security concerns, and the need for robust infrastructure to support these advanced systems is obviously evident. I mean, if you follow anything with sort of technology space and innovation, and you'll see that Tesla invested billions in sort of AI recently, and so is Apple and everybody else. So it requires significant infrastructure to be able to advance these systems. Collaboration between AI developers and emergency management professionals will be crucial in addressing these types of issues and safeguarding ethical norms and societal values. As we delve into today's discussion, let us approach these different aspects with a pragmatic stance in terms of what can we do today, what does the future hold, and what are the risks, and so that we can really talk about technology and building more resilient societies, even globally. And so as we go through this, I just wanted to show a couple of recent articles in terms of what's been published. And there's a couple of things that I wanted to highlight, which is that really take note of sort of the years here. This is sort of a large image. It doesn't show you where it's coming from, but I think it was from nature.com or a Nature publication. But basically, it's talking about the use of AI in natural disasters and sort of frequency and ferocity of how climate change is impacting our societies and the risks that we face. But notice this was from 2020. And then as we progress, we start to see that, of course, in 2022 and these other sort of articles are coming out, we're starting to really enhance this conversation about the use of AI, machine learning, and other technology and towards natural disaster management and fostering collaboration in these and through the use of various different models. And even I pulled this article this morning just because it mentions that even in, of course, naturally in Africa Union, it's working on disaster risk reduction as well in some of the programs in Africa. These are generally larger international programs which are exploring the use of technology like AI in terms of improving disaster risk reduction. And I think that's where we see a lot of focus lately is in the mitigation and sort of prevention space. So really within the planning and analysis space and all these data points and risks and hazards and analysis. And that's where we're starting to see a lot of it, and less so really in terms of what we're seeing on the response side. But it's not impossible to have AI support response. It happens in terms of resource allocation with wildfires in California and some other floods. But again, another article that we were, that was coming from the UN that was talking about the use of AI back in 2020. So this has been a longer term conversation, but at the same time, this didn't sort of explode onto the scene until we started having OpenAI, ChatGPT, and these other tools that become commercially available that are able to bring this to a daily user. And so one aspect I want to explore on this panel and with Tom and Session, especially, and we'll get to their introductions here in just a second, is really what can we do? We understand that these tools can be used at the level of the UN, right? So massive disaster risk reduction platforms and these international programs, well-funded research supported by academia. But what can we also do at an end user level? How can we leverage AI for the individual emergency manager, for the individual person working in a city administration, emergency response person, so the fire chief, the police chief, public health officials, what can we do and how can we leverage AI on a daily basis to enhance our performance and our abilities to respond effectively, to mitigate risk, and to be able to plan and work in with our societies? And then there's some information that's coming out more recently, but this is just 2021, but for in disaster response. And so one of the things that they talk about in terms of disaster response is really just in terms of resource allocation. So studying resource allocation, managing personnel, and just the logistics side. So using all the data compressed together in terms of machine learning and predictions, and then be able to determine where resources are best allocated, and then what is the way to do that. So this is something that we can also add into this discussion, but I think we see less and less in terms of AI in the response piece, because that's very human-centric, and more in the data analysis piece itself. So with that, I'll just go ahead and close this and stop sharing, and I'll turn it over for quick introductions, starting with Tom, and then over to Session as we move forward. So Tom, over to you.
Yes. Hello. Hello, everyone. I'm speaking to you from the west coast of the U.S., where it's getting close to midnight. And very glad to be talking with Kyle and Sachin about this topic. Let me introduce myself first. As mentioned, I am the director for North America for TIEMS. I'm also principal of consulting firm called Thinking Teams, whose goal is to harmonize human and machine intelligence. And so I've been particularly interested in that regard in how to use AI and how AI and human beings can work together. And so one of my foci has been, Kyle was just talking about how AI can provide some great tools for emergency management. And there are some great ones there, and including, trying to predict and arrange response to particularly natural disasters is a lot about recognizing patterns and being able to do predictions. And AI is great at that. So, for example, there have been tools that have been developed to predict the impact of floods based on rains and so forth. Of course, seismic signal analysis and that sort of thing. So there's a rich field there. However, most recently, I've been interested in the risks of AI and how we in emergency management can play a role in mitigating those risks. So that's probably going to be the focus of what my part of this discussion will be.
Thanks. And Sachin, we'll head over to you for a quick introduction. Let us know your background, because I think that's critical to our discussion.
Yeah, definitely. Thank you for having me, Kyle, and thank you also to Thomas. So my background is I have been trained in cybersecurity and cryptography. So coming from a security background, and over the last 10 years or so, I have built many technical companies. So the last one was in deep learning space. So we built a traffic monitoring company using deep learning methods before I moved to Norway. And here in Norway, I'm working as senior advisor coordinating AI research for Norway. And as you agree with me, maybe that the field of AI is moving very fast. So, the decades of progress is happening sometimes in a matter of months. And would be very happy to learn more through this discussion and also share my observations, as you lead the discussion, Kyle. Thank you.
Thanks. Appreciate it. And so one of the things that's, when we talk about the use of AI, so it obviously comes to the main topic, and I think where it's been most effective for a long time is in prediction, right? So data analysis, prediction, looking at hazards and risks and geospatial and everything else that goes along with that in terms of getting through all of that data and being able to come up and identify common components of data, to look at common themes, to be able to connect information that we just simply we're not able to do with our own intellectual capacity, unfortunately. And so this is something that has been, I think, going on for a number of years. And so there's been a couple of cases where this was used in a little bit more in depth that I could just highlight very briefly, and then we'll lead into a discussion, I think, Sachin, coming back to you. But in terms of like California wildfires, so AI became a vital tool in disaster management with some very specific aspects. So AI came in with predictive analytics. So the algorithms were used to analyze these vast data sets that we often deal with, including the weather patterns, topographical data, to predict a potential spread of fires. And that information was crucial in developing evacuation plans and deploying resources effectively. There was also, and we've seen this in some of the presentations from this week as well, in terms of just image recognition and analysis. So the various different aspects of using AI technologies and machine learning coupled with satellite and drone imagery, in this case in California wildfires, assisted in identifying the affected areas more swiftly. There's also the damage assessments that are being done, with FEMA in the United States. But that is also enabling real-time monitoring of the fire's progression and helping to strategize a response accordingly. So that's also something that we're starting to see come over to the response side instead of just on the risk reduction side. And then, as previously mentioned, the social media analysis. And so that was happening in California as well in terms of gathering information from updates from residents and then providing insights into real-time conditions and then helping identify where needs and resources should be allocated. So that's just one example of where AI was being used in terms of not only the risk reduction piece, but also in the analysis piece, and then as well as in starting to get over into the response side. But in order to do that, and you mentioned, Sachin, there was a lot of, things developed very, very quickly in terms of, this has been a topic for decades now, right? And you've built your career around this. But all of a sudden, OpenAI comes out very recently, and now everything is new and fresh again. And it seems to have accelerated very quickly. So what was this last year like in terms of AI developments and then the opportunities it's presenting to not only moving from larger institutions, but to the individual?
Yeah, I think it's a daunting task for me to capture this, like a 1 year journey, but maybe I'll still try to attempt. So I think in 2017, was when some of the researchers in Google wrote this paper. It's called Attention is All You Need, and which gave birth to this architecture called as transformers. And the fundamental aspect in this discovery was that if people were finding it difficult to train AI models faster, and this transformer architecture enabled training at a larger scale. And at around that time, let's say, or maybe a year or two later, OpenAI started with this idea that could they train transformers, pre-trained transformers, and could that acquire capabilities which are emerging capabilities. So these basically they started taking internet scale data and they started building these pre-trained transformers, what we call as GPTs. with their versions GPT-1, GPT-2, GPT-3. And as we saw that coming in the last few years, I think it was around GPT-3 that the world started to notice that something is going to happen here, because fundamentally speaking, these models, they were basically just to predict the next word sequence in a language context. So if you have a sentence and could you predict a missing in the sentence. But what emerged was that when you have internet scale and when you have a model which is running into hundreds of billions of tokens, it started to have much more nuanced capabilities. And somebody wrote a paper, I think it was last year or so, which was very much in news. It was called Sparks of the Intelligence. So people started to confuse it with artificial general intelligence. So what we call these generative pre-trained transformers is also people call them as large language models. And now we see beyond that, which is even multimodal models, meaning they have been trained not just on language data, which is text, but also on voice, video, and other kind of modalities. Is that we are able to produce, a lot of intelligent workflows. So let's say, as knowledge workers, sometimes we are into summarizing of documents. So one of the capability these large language models offer is that you can give them a large piece of text and they can give you a very quickly a half a page summary. Now, could this be useful in certain contexts? Yes, definitely it is. Maybe for busy executives, it can give them a summary of daily research which is coming out. Then another very interesting thing, Kyle, in the context of disaster management is that imagine you have 500 set of documents and somewhere you have to refer them to make your plan. So these large language models can also help us to answer particular questions. So they could be also tools for question and answering. And all these kind of tasks, many of us have tried in November last year with ChatGPT, and people started with summarizing, with asking question and answer, all kind of tasks people started to do. And I think in the history of humankind, ChatGPT became the application which got maybe the first 100 million users in a matter of few months. So it was the most viral application that OpenAI built. And around the same time, let's say Facebook started to build, their own version of language model, which was called Llama, and they were giving it to Stanford. And in that process, the weights of the model leaked, and this was in April earlier this year, and that changed the world. The reason I say so because the open source community got hold of it and they started to replicate it. So now we have many large language models which are trained on internet scale data from Facebook, from many other companies like Mosaic, Claude, and so forth. And why this is changing the paradigm is because when OpenAI does this kind of a thing, they probably spend tens of millions of dollars, or in case it could be hundreds of millions of dollars. So people like you and me, Kyle, we cannot afford such amount of resources to train such models. But when these came to open source in April, and subsequently Facebook released the second edition of Llama, which is also by license allowed for anybody to use. So imagine a capability which was only available to big tech, a year before, is now available to anybody who is like you and me. Now, what is that we can do with this capability is, I think, we are starting to see. And the first capability or the first manifestation that we are going to see is that, at least I can say that there will be at least a billion chatbots in times to come. Now, what these billion chatbots can do, it really depends on, like you started your discussion now, that what can end user do, right? So what can Sachin Gaur do? What can Kyle King do? What can Thomas Robertson do? So the question here is that it is our imagination, and maybe the use case and the curation. So maybe you are a long-standing professional in this domain, and you have all the kind of important specific documents that you have collected that you think an emergency management professional could be referring to when they're making plans. So one of the things that you could potentially launch is using these technologies is that the curated data that you put that in the backend, you put this technology in the front end, and then you're allowing an emergency management professional to to do a question and answering which is specific to a domain. Now, imagine we talked specifically about California, and I think this is going beyond now AI. A big enablement here is the advances that we have in the space research. So now it has become very easy for people to launch satellites. And there are also projects here in Europe. Since you are based in Berlin, you are very much aware of Copernicus, for example, where we have access to satellite data. And Thomas also hinted onto it that AI enables us to find patterns. So when we are looking at satellite data, and specifically if you have custom satellites, it's possible to get data also at a very specific frequency, which can be also in a way real time. Now, if you're looking at forest fire, for example, so before it grows big, can we give an alert in real time to a forest officer? And I think these are the kind of applications which can be built end to end today. You know, only and only in this case, satellite imagery has become what you say. It has started to become commoditized, and since it has started to become commoditized, it is possible for us to run some kind of AI algorithms on it and build custom alerts. I would like to just give very one specific example. Sorry, I'm taking a bit longer here, but there is this Norwegian company. I'm forgetting the name, but they started working on this imagery data to track pirate ships in the sea. And they realized that for them to get real time data, because they were earlier depending on the European satellite, so they were not getting it in the frequency that they wanted. So they are now into launching of their own Pico satellite, and they are selling this use case to the Dutch Coast Guard. So if there is a ship coming to the Netherlands and which is doing some illegal activities, now the Dutch Coast Guard can get a message when the ship goes off the radar, and they can take action, in that real time window when the ship goes off the radar and let's say is trying to smuggle something. So these kind of specific cases for a startup to build, I think it was not possible 5 years ago. And today, end to end, you can build and think of such custom use cases. So we are definitely in interesting times with enablements from satellite and with enablements from AI. So maybe I can stop here just to allow you to, maybe build on this, and maybe Thomas can also contribute. Thank you.
No, thanks a lot. I think that's great. That's a great discussion point we can build upon. So Tom, coming back to you, I think one of the key things that we're seeing here is, and Sachin had mentioned it, it's sort of making things accessible now, making big data accessible in a format and in a way that we can use it as community leaders, emergency managers, academia, whatever the case is in our professional fields. But what is the impact on how this changes organizations? Because there's obviously going to be an impact in terms of speed of analysis, speed of decision making, and things like that. But at the same time, and I'm sort of going into I'm going down a rabbit hole myself, right, so to speak, in terms of analyzing this. But I would also think there's inherent risk with that, right? So you're making decisions based on, you don't have the opportunity to really review data. So there's a lot of trust in the AI model, in that sort of bot, like, Sachin was talking about. And then you're basing your decision on it, which may have a large impact. So what are your thoughts on how this is going to transform the way organizations work?
Well, I think that one of the things that's in our discussion will be good to differentiate is, and Sachin mentioned this, is that today, probably 90% of the headlines that mention AI are referring to large language models. And that's because they're emerging relatively recently with surprising capabilities. So that's one category that we should talk about, because it's having a huge impact right now, and it's going to have a particularly disruptive impact. There are other types of AI applications, as we've alluded to earlier in the discussion, that, for example, analyze satellite images, look for patterns in data, to predict the occurrence of problems, to find evacuation. So there are other things as well. But I think that probably getting back to large language models and how it's going to impact organizations, extremely useful to be able to pose a question and draw on the information contained in billions of words of text, which is what these large language models do. And in a way, what it does, it's able to do that, and it's great that the very high investment, as Sachin mentioned, it's cost hundreds of millions of dollars to train these models on billions of items of text. And what that does it's created a very large baseline model that essentially contains, quote, the knowledge that's contained in all that text. And you can then leverage that a couple of ways. The most direct way for us as consumers is you can just pose queries. You can engineer prompts to get ChatGPT to provide things that you want. And that's a huge productivity enhancer, whether it's writing memos, letters, doing a lot of the routine kinds of correspondence and text building, which, let's face it, all of us, particularly who have office work as part of our jobs, there's a lot of time that goes into that. And this is a huge time saver, and it's going to be a huge impact on that kind of work. But so what are the risks there? What are the limitations? Well, one of the well-known risks is that large language models can hallucinate. In other words, they can make up stuff that sounds very authoritative, but it's actually false. And it takes someone who's already an expert to be able to double check that and find it. So I think that many applications, use cases of large language models, they work best when they're working side by side with somebody who really knows their stuff, and they can be working with the large language model kind of maybe as a junior assistant, something like that. And that works great in software development, for example. Large language models can write software, and it can be a huge boon to software engineers. I've heard them say that it definitely boosts their productivity, because a software engineer, for example, if you're writing an application in a program language like Python, one of the ways you leverage past work is there's a huge number of libraries that you can take advantage of with just single line calls to be able to do what you're trying to do in software. And GPT-4, for example, has access to far more of these libraries, Python libraries, than most software engineers would ever be able to learn. So when you're asking GPT to come up with a draft of your computer program, it'll come up with libraries maybe you've never heard of, and if you're a programmer, you can check it out. So it's and you can also find errors in it, and that's high leverage. But because one way to look at the way these large language models work is that what they're doing is providing you kind of a, when you ask it for a particular output, like, write me an essay on applications of AI to emergency management. In its billions of training samples, billions of items of text that it's looked at, there's all kinds of mention of emergency management and AI and so forth. And in a way, what you're getting in its output is kind of it's almost like an average of everything it's seen. It condenses it. And so it's not too surprising that when it does that, every once in a while, it'll come up with something that's kind of in between two facts, but not quite right, because the in-between doesn't work. So, for example, GPT models are notoriously bad at arithmetic. So even if you train them on, multiplying two 5-digit numbers, something like that, something a human can do accurately, it's very hard to get them to do it correctly, because GPT has this sort of pulling in all this information and then giving you sort of a combination of it that's not exactly anything that it's seen, but it's a summary or an average or an extrapolation or interpolation. So that issue of you have to be careful that it doesn't, because it can hallucinate. That can be a problem. That can be a risk. The other thing is that if you're using these large language models, or even any of the other broader models that recognize patterns and take advantage of deep neural networks, which are the kind of neural networks that have millions or even billions of parameters, and it could be a neural network that's doing recognition of radiographs or recognition of images and so forth. You have to be sure particularly this comes up in the medical profession. If you're using AI to look for patterns and help make medical decisions, it can be difficult because there's this problem of lack of transparency in the large language models. And in fact, any of the deep learning models, they are so complex that it's hard to, unless, and there's research being done on this to try to make it better, but it'll come up with an answer, but it can't explain the answer. So it makes it harder to verify. So this lack of transparency can be a risk when AIs are employed in an organization to try to help make decisions. So that requires, careful building of or integrating the use of AI in the broader decision-making process in order to get around that difficulty of it not being transparent. Earlier, other kinds of models for decision-making, like statistical models, straight statistical models, it's easier to see how you came up with the answer. You can draw distributions and you can see, well, this is where the threshold ought to be, and it's easier to visualize. But when a decision is made based on input data rattling through billions of artificial neurons, it's just sort of hard to see where it is. So I would say hallucination and lack of transparency are two big risks that people involved in organizations have to be concerned with. And there's more, but I'll pause there.
Thanks, Tom. And I think that that's something that is going to be very difficult to get around. But in terms of the future and what we're looking at, well, let me pause on that for a second. So in terms of organizational impact, and Sachin, we'll come back to you. So what, for our use case and the way that we use AI is almost exactly in the same way that you were talking about. There's large repositories of documents that we go through. And I'll use an example here because I think it'll illustrate the point. And I would also ask our audience with Roman and South Africa their thoughts as well. But one of the use cases that we have, and one example, is that every large organization that is involved in any sort of response capability has done exercises, and every exercise has an after action review. And to be honest, once you do the exercise and you go through the after action review, you're probably never going to read it again. So it sort of gets filed away as, some feedback. But what if you had the ability to go through 10 years of after action reviews and thousands of documents and say, what were the top 3 things that we need to train on as an organization to improve our response capabilities? What were the top 3 issues or challenges from the last 10 years of exercises? Where should we focus as an organization to improve our personnel, our training, our equipment needs? And so you're able to go through all of this data, and you're able to sit there and ask it questions and build and mold and answer that you can then use without spending thousands and thousands of hours trying to go through and do it manually. We use that. That's one use case that we've actually talked to very large organizations about, that they have seen significant value in that, because you can simply take it and say, okay, I'm designing the next exercise. So what are the 10 points? Give me 10 points that need to be worked on from the last 10 years of exercises that we should do or integrate into this exercise that will help us improve as an organization. And so you're able to capture these larger thoughts about organizational development and things like that, but get through that data analysis piece and to integrate that into some of the work that you're doing. So, but to your point, Tom, and I think it's important, we don't know how they get that actual point, right? And so this is inherently the risk that we're seeing is that, that it sounds great. It absolutely, it makes sense on the surface. It passes the first read, but if you get an expert to actually look at it, so many of you in the audience are professionals, and if you review it, it's pretty good. It's a 70-80% solution, but that 20% could be really critical, right? And that could err in so many different ways and send you off a complete different path that you wanted to get on. And so that's where I think, in terms of the AI use in organizations, it's going to be very instrumental in sort of these large data sets. But Sachin, I'd like to come back to you if you're still there, and just to basically get some feedback in terms of how we're going to address these challenges of sort of the data integrity piece, any sort of misleading or hallucinations, and I'd also ask to expand a little bit, because your point in terms of open source, I think, was really important, because the future is probably not with these huge models that are absorbing everything, right? Because then you have, the more data you have, the more at risk you are in terms of contaminating the output, right? Just in my mind anyway. So if you're studying, it's sort of like the expression of, if you're an expert in everything, you're an expert in nothing. So that's where maybe these focused vertical models with local application are going to really be the future. So we have our own AI for our own organization, for our own county, our own district, our own use case there. So I'd love to hear your thoughts about that.
Yeah, thank you, Kyle, and excellent points made by Thomas. I agree with all of them. And just to give personal anecdotes here, I've been using a chatbot. It's called Pi. It's by a company called Inflection.ai. So Bill Gates, Reid Hoffman, others are investors in this. It's really seductive and, kind of addictive chatbot. I was recently landing in Edinburgh, and I had to reach Newcastle in UK. So I asked the chatbot, what is the distance between Edinburgh and Newcastle? And it said that it's 45 kilometers, and I could not believe it. So I asked the chatbot, how confident you are that it's 45 kilometers? It said, I'm damn sure. So this is the trouble, or this is the one, unfortunate future we can be, that where, these kind of bots could be very, very confident in misguiding us. And if we are moving into an era where Google gives us millions of results versus a chatbot giving us one definite result, if you don't put your common sense to use, then you are in trouble, right? So I'm sure that Inflection AI kind of tools will, since they are raised billions of dollars, so they would probably overcome this someday. The another similar example from Inflection AI is that I was landing into Delhi, and I asked, give me recommendations of vegetarian restaurants. And it gave me 5 recommendations. And I asked, what is the basis of these recommendations? And it went blank. So again, to the point of Thomas, that, it can give you the answer, but if you want to know what is the basis of this recommendation, so it went blank. So to me, like you said, Kyle, if you're a real expert, then you will start to see cracks in this. And that's where I think we don't have to use the large language models as knowledge source. So we have to diverge from there, and we can remove the problems of hallucination. So my use case, which boils down to your field of disaster management or emergency management, is that use large language models as a knowledge, not as a knowledge engine, but as a natural language understanding engine, just to pass the natural language. And the new era of applications that is emerging now, which are called vector databases. And there is a popular open source framework again, like LangChain, or you could use vector databases like VV8. So what they allow you, Kyle, is that you gave this example of 10 years of last exercises. So this exercises are not known by OpenAI, or not known by any of these models, because these are your private data. So in this architecture, what we do is we take one of these open source large language models, let's say Llama or something like that. We privately host it. So when a query comes from the user, all the large language model is trying to do is to understand the query. Now the query, the beauty or the value add the large language model is still doing for us is that it can be in any language. It doesn't matter to us. It doesn't have to be just in English, right? It can be Arabic, it can be whatever, right? When AI is converting this query into something which AI understand, that is vector. So that is the beauty of converting, multimodality data. It could be even an image, it could be even a sound, all of it is converted into a vector. And what we are doing is essentially in a vector database, then we are searching this vector against other vectors. And what it returns is something which is semantically closer to it. For example, Facebook has a model which is called image bind. So they have trained 5 modalities of data together. So if they have a sparrow, they have the sound of sparrow, they have a 3D model of a sparrow, they have a video of a sparrow. So in this model, if you give the sound of a bird, it will give you the exact species photo, for example, right? So imagine what is the beauty of this model is that you're not using the large language model for its knowledge because you're not sure about it. And if you are in a high risk application area, you don't want to take that risk. So you want to rely on your own thousands of documents which are curated. Now, again, what is the danger here? That imagine I'm asking, give me the latest or give me the policy on evacuation, for example. And let's say in your 1,000 documents, you have 5 policy documents from different years. Now, the large language model and this vector database helps you find the policy from your document. But since it finds it at 5 places, which policy it should give it to the user? So I would like to distinguish at this point from the perspective of a verified response and an unverified response. And when Thomas said that, if you treat AI as a junior assistant to you, and if there is an expert working alongside with it, so what we can do is we can actually build and design a system. And this is what I'm doing right now, is to design a chatbot architecture wherein we use unstructured data. So I'm calling these thousands of documents as unstructured data. A query happens and we find a response, but what we don't know whether this response is a good quality response or a bad quality response. So we bring in a human to rate this answer. And this is what OpenAIs of the world have done. So they call it reinforcement learning human feedback. So a human is giving a feedback, is it a good answer or a bad answer? And maybe a human can even augment that answer. So imagine we store those query and answer in a separate database, and we keep building from unstructured data to structured data. So next time when a query happens, we can actually check both the databases. So if we find it in the verified responses, so instead of something that is unverified, we can actually give a human verified answer. So in this way, we can have a scalable system. If there is a query which is being repeated, maybe we can give an answer for which we are bit more confident, where Thomas said his point, that which is, let's say, verified by an expert in that sense. So maybe I can stop here. I don't know if I answered your question, Kyle.
No,
Okay.
I think that's good feedback. Let's go to Roman. And Roman, have you got any comments or questions from our audience?
Thank you, everyone. That was really cool. I especially like the thing that you're converting information into a different realm of understanding. That vector conversion is also quite critical to education in general. So I think that might be a way to link AI with training in emergency and disaster management. So what we thought at the moment is, since we've been talking for a while on the side of the speakers, are there any questions or comments anyone would like to make from the podium? If you do, please come forward and share your insights with us. Thank you.
Good morning to the panel. I'm Owen Becker, and my particular interest is in the education field and using simulations. Now, it is, I know it's possible, and I always say that you've just got to find somebody that writes the algorithm that links all the tools that you have available. But as a disaster manager, if you have never experienced an earthquake and searching through rubble and buildings that have a potential to collapse, how do you train somebody for that scenario? So using AI, you create a virtual reality for those people to operate in. Is there anything available, or is it something that we can look towards? Because you might go your whole career never working with an earthquake, and in your last year you're suddenly faced with one. So that's why it's important that we equip our students and our practitioners with the ability to experience different scenarios that they may never experience in real life. Thanks a lot.
Yeah, thanks. That's a great question. I'll kick that off because I come from the emergency services myself, and I have a couple of specific points about that, and then I'll turn over to Tom in session in terms of the technology piece. So one of the things that we have done, and so you'll start to see virtual reality and possibly augmented reality come into the response side, especially in the case of, like you mentioned, with earthquakes and search and rescue teams. But one of the key things, and I've experienced this myself because I've been in rescue operations, is you can never replace the real experience. And so this is something that's absolutely critical. And the reason why I say that is because while we can do orientation with people in the education and training space and sort of in that cognitive domain, and they start to be able to understand what they're getting into, and they start to get oriented to the environment they will operate in, one of the challenges is that you cannot plan with, because you cannot actually feel it, is when you get trapped in rubble yourself, or when you get claustrophobic, for when your equipment fails, for when these things happen and you have physical stressors that will temper your response. And so for me personally, I was trapped in a building in a fire and had severe claustrophobia and all that stuff like that. And that was an experience that you have to actually live through. And so you have to actually work through that physical experience to have that physical interaction. And you always want people to train as they operate. And so what we've seen in education and training domains and mostly a lot of other security fields is that it's been great in terms of accelerating learning by providing orientation and understanding through the use of virtual reality on how to use equipment, how, and things like that, get through the mechanics, get to understand the principles, and get to understand the foundation, so that when they do respond, they're able to understand the environment they're operating in. But what we can't do is replace that physical experience, the physical trauma and physical limitations that each person has in terms of their own response capability. And so I'll leave it at that, and maybe Tom or Sachin wants to go next.
Yeah, I've seen some interesting uses of virtual reality and simulation for training for both professionals and for the public. And this, I haven't looked at this for some years now, but for professionals, I've seen two kinds of virtual training. One kind is at the kind of the command and control level. So you will have a team that maybe an emergency response team at a centralized location with screens and making decisions. And the simulation will feed back the real world. You can see the consequences of your decisions. You can sort of get work through some aspects of teamwork in handling it. So that's kind of at the command and control level. I've also seen like smartphone apps that have been used successfully for training. They're not, well, in a sense, they can be immersive because you can combine those with, being in an exercise out in a facility, and you can sort of have at least the physical outlines of things in buildings, and the app can tell you, okay, now this is your situation. And of course, it's more realistic if you can simulate it. I was in one of our team's conferences back in, I think it was 2014, it was in the south of France, and it was at a fire brigade, and they had buildings set up so that firefighters could experience having to crawl through difficult spaces with a lot of smoke. So stuff like that is always more realistic, but you can, even with some of these smartphone apps, experience some of the teamwork. And it's surprising. I was involved way back when very relatively primitive visual simulations were used in networks to try to train army platoons, tank platoons. And in spite of it was obviously kind of it wasn't photorealistic back then. The computers, it didn't need to be. Sometimes just enough to elicit the feeling that I'm in this situation. How do I get out of it? So that can be useful for the public. And I think you may have seen some of these earthquake simulators where you get on a platform that's got hydraulic actuators, and you'll sit in a room and you get to actually experience what it would be like to be in a Richter scale 5 or 6 earthquake. And and they've even had those at theme parks, such as places like Disney, where they simulate bad weather situations, even flood situations. And that can be very important in terms of awareness of the public, because that's always one of the challenges. A lot of the mitigation actions that are going to need to be taken in the event of a disaster need to be taken by the public. And there's this challenge with getting them to respond effectively, because it's not real to them. But so going through one of those simulations can make it real. Like, since you've been through your own personal experience, Kyle, I'm sure the next time something like that's happened, that will inform your sense of urgency and your actions, right?
Thanks, Tom. I want to add 2 quick points to that, and then we'll go back to Roman. But I'll draw from 2 different domains. So the emergency services domain and response side, your point on command and control and information and data is extremely important. And what we'll start to see in the future is augmented reality, in terms of, you have on your face mask and you'll have a visual screen, and then you'll be able to project information to responders so that they're able to, we combine the data, combine the command and control, maybe some predictive analysis and things like that, but that information is fed to the responder in an augmented reality portion. And then I want to draw from a different domain completely, because we've worked in this in the work that we do, but we've started to see really interesting, and interesting is not the best word here, but innovation in terms of the war in Ukraine. And so it's changing the way that people operate. And what you start to see, Tom, reflecting on what you said, is it's changed the nature of military operations because of all the drones. And you start to have leadership that takes a step back and is using drones and screens, basically like out of a movie, on their wrist, and they're watching to see how things play out on the battlefield, and then giving people directions on where to go, on real-time analysis and information. So I think that it's changing the nature of the way that things are being done, and it will happen in the response field as well, and it will sort of come over in those advances as well. But Sachin, let's go to you for some technical feedback on that.
Yeah, very quickly, I just wanted to mention that I've been an Oculus user for a couple of years now, and I'm quite confident that although I haven't checked it, but there might be certain applications already there which can allow people to, in an immersive way, experience this phenomena. And on my phone, which is an iPhone, has a LiDAR sensor, and I have been already for last 2 years not taking photos but 3D scanning, statues and artifacts. So I'm just wondering, this capability for a layman like me already can allow, let's say, to an expert like you, send an exact 3D model which is, correct to 2 decimal places, and maybe you can help me, remotely in that way, to guide me, in certain situations that I can imagine. And the last thing I want to say is that I think DARPA in US has always been very futuristic in funding, challenges. And I think it was already a couple of years ago after the Japanese nuclear incident that one of the DARPA challenge was to design a robot which will exactly go and do the same set of operations that the humans did in the nuclear reactor. So DARPA, and this challenge was successful, and the people were able to design this robot. So I also feel that the world we are moving into, that we are probably not appreciating at this point today, but I think 2 years down the line, there will be far more robots available. Because the way AI is progressing with robotics, I think we are going to have Android kind of robots which are going to perform human-like tasks. So I think Tesla is having their own robot which is working in the assembly lines. And I think there is also one company where OpenAI has invested in Norway. It's called Hansen Robotics, which is now changed to 1X. So these are kind of robots where we can imagine scenarios where we don't want to send humans into situations, but maybe we are remotely guiding these robots to perform the tasks that humans would have done. And there's another Norwegian company which is called Cognite. It's using Boston Robotics, dog, which is called Spot, a lot in the oil platforms today already to do some kind of surveillance. And I think it's coming with a 5th arm now, which can at least has a maneuvering capability to open doors, because in an office space, many times you have to open the door, and a robotic dog cannot navigate until it opens the door. So I think one of the game-changing scenario here would be that more robots will come into these kind of risky situations. I can stop here. Thank you, Kyle.
Thanks. Roman, back to you.
Thank you. Are there any further questions? Yes, let's go to Renee first and then Chris.
Hi, I'm Renee. I'm a colleague of Roman from Rhodes University. And so mine is more comments from an academic perspective. So, Kyle, you also mentioned how, AI has, we can say disrupted, has improved, has enhanced. But obviously in academia, AI, obviously it turned our whole world upside down. Because now students were writing beautiful, in-depth, detailed assignments. So obviously for us, a change in assessments, where now you build in like critical reflections, which relies more on human capabilities. But I mean, obviously we've had to embrace it. There was no way we could resist it. It was going to be a part of our lives. So obviously adapting, turn it in to build in, the ethical applications to be able to actually check for AI, and if it was the more human aspects to it. And then Thomas, you were talking about, and I was laughing about the hallucinations and the false information. And I've also seen assignments where I've checked references that do not exist. Yeah, so it's beautiful things that I'm like, I would also love to read up further on this guy that wrote this. But now it does not exist. So
Yeah,
obviously
it's very inventive. You know, it's surprising. It'll come up with, I mean, you didn't tell it to come up with a reference, but it'll give you a reference that doesn't exist. Yeah.
Exactly. So, and it's very interesting information. So obviously you would also want to learn more than, you know, that person, and it completely doesn't exist. And funny enough, there was a case in South Africa where, and it was, I think it was last month, where a magistrate in a court was furious because lawyers were referencing cases that does not exist.
Yeah.
So when the magistrate was just interrogating them a bit more, they got it from ChatGPT. So now they're building a case on cases that were given by ChatGPT that does not exist. I was laughing as I was reading this in one of our Sunday Times, because building a case now on something that does not exist. So you're absolutely right there, yeah, Thomas. It's actually hallucination. Then session just last yesterday. Vinod was presenting, and I was also reflecting on it specifically as it relates to, you were talking about real-time data, and that's also what I was asking about yesterday, because he was talking about multi-hazard assessments and, you know, the importance then of multi-hazard capacity building. And I was just saying, in my own research in the South African local district and local government context, that the issue very much is, as it comes to multi-hazard assessments and, you know, mitigating and preparing, that it's not always based on real-time accurate data. So it could be based on data of a few years back or data that's in. So that's why the interventions, the mitigation and the response planning is then based on data that is actually outdated. So
Yes.
I absolutely agree with you on that session, that because I mean, we're talking about saving lives here, and if you are using data that's outdated, then obviously, you know, there would be implications then for that community that is affected. So I absolutely agree with you on that session, and maybe you also have some ideas around access to real-time data. Vinod did yesterday give us some ideas that governments, maybe at a national level, but also maybe at a provincial and a local government level, can tap into real-time data that also then ensures that interventions, mitigation and preparedness is based on relevant and accurate data. Thanks.
Yeah, I have,
ahead, Tom.
that brings up a couple of things for me. I mean, one of the challenges is that you're seeing this stuff because when these large language models came out and were made available to the public, the inventors of the models, as well as the public, are discovering as we go what their capabilities and limitations really are. And as Sachin mentioned, as research continues, I think that there will be, people will develop better workarounds for some of these issues with false information and so forth. But one of the really important things is, you know, for example, ChatGPT, GPT 3.5, I guess, is what became available first. It was based on data only up through, I think it was 2022 or maybe earlier, I can't remember what. But anything that happened after that wasn't there. So I think it's, as you say, real time, probably one of the biggest risks to an organization that's going to use AI, which is generally speaking very data driven. You have to be really clear on what data is going to be appropriate. And if you're using climate data that doesn't account for example, climate change these days, you're going to make wrong decisions.
Kyle?
Yeah, thanks, Tom. Thanks, Roman. So yeah, great points all the way around. Nobody can argue with the impact on academia. I think just very briefly, one of the ways in terms of real-time data that we are looking at trying to explore is in terms of community building, urban planning. So in a lot of the nations that we have gone to are what we call post-conflict, and they're in a stabilization phase, and we're recovering in these communities. And so you can also look at it from a disaster recovery perspective, and how do you rebuild these communities? And so you need updated real-time data, real mapping, real geospatial, real sort of recent and relevant information to be able to plan to rebuild these communities. But then you get into the same sort of space of where, okay, we're making a decision today on a Wednesday, and then in 5 years, is it going to be the same? And so we're already making decisions on the data that we have currently available, which is going to tell us the floodplains, the fire risks, the exposure risk from industrial chemicals and things like that. We're going to plan our communities around it, rebuild our communities. But at the same time, that data was only a snapshot of today. And so how does it continue to evolve over time? And how do we manage the evolution of our communities and the urban design and urban development piece to make them more resilient? And that's one of the real catches that we have with real-time data. Real-time data is great in the response. And if you can feed that in and incorporate that to your response, it's a lot more effective. However, when you're doing sort of those static decisions and investment and capital investment, it becomes, sort of a catch there. But, honestly, it's nothing that we haven't done before in terms of governments and administrations, right? You make a decision with the base information you have. Thanks. Okay, next.
Chris.
Aloha. I'm Chris Chiesa, the Deputy Executive Director from the Pacific Disaster Center. We're headquartered in Hawaii, although we do have a global mission. I have more of a comment and invitation for the three of you that won't join us at the coffee break. I probably wouldn't have posed a question. I would have just, grabbed you in 15 minutes at our break. But just wanted to mention that PDC has been using AI in disaster management, primarily in early warning and sort of filling some of the gaps that exist in data, as well as helping to streamline and formulate interpretable, understandable warning messages. In that program or program area, we call it AI for Humanity. If you go to our website, I guess that's my invitation. If you go to our website, pdc.org, and if you miss that, Harold or Roman can connect you to our organization or to me personally, or my email address I won't rattle off right now, but can connect you. And if you see opportunities for collaboration, that's why we're here physically or virtually. So I wanted to throw that out. I'll just mention very, very briefly that one of the things that we do is use AI to help us fill some of the data gaps that exist. Some areas like earthquakes, there's been global coverage for a long time that we get that signal quite quickly. Tsunami, similar. You'll see in my presentation at 11, for those of you that join, and of course those of you that are here, you'll see that we teamed with NASA to help with flood, landslide, and wildfire hazards. But there's others that aren't detected from space and so forth. And so we have some routines that go through tens of thousands of news sources and social media and so forth, and queue those up. And I think the point that's been made numerously is that not everything that gets spit out at the end of an AI algorithm do you want to throw out there on an alert network. And so we queue that up for our disaster management analyst to go through and say, yes, add it to the system, no, don't. In that process, by the way, it's a machine learning algorithm. In that process, that list over time gets better and better. So those are some of the ways that we're using AI to help keep people safe around the world, and take a look at the work that we're doing. Send a note to info@pdc.org, or you can get my credentials from Roman and Harold, and we'd be happy to further a conversation. That, of course, goes to the same for all of you that are here, but we'll be adjourning to coffee shortly. Thank you.
Yeah, thank you.
Yeah, thanks. I appreciate that. I actually know Steve Recca from PDC, and we're actually doing some work through an organization called ISG that we support as well. So small world, and happy to see you're involved in the conference as well.
Yeah, Steve and I will be working together next week in the Balkans. So I'll let him know that I saw you virtually.
Yeah, we were just there in the Balkans as well. That's where we saw each other. So all right,
okay.
Thanks.
We're in a couple different countries, different program, but in any event, I'll let you know. All right, aloha.
A couple of things that brought up for me. One is, it sounds like that's an example of something really important, figuring out the right level of human intervention when you use AI. And it sounds like you've really worked that there, which is great. The other thing that came up, I think Sachin made a great point, and that this is more at the deeper technical level as the AI evolves, and those of you who are involved in the development of models, is that if you look at the large language models as not your primary source of knowledge, but simply as a device that knows a lot about language, you can take advantage of that. I mean, it knows how to form sentences. It knows how to be coherent in a way, but it also can be configured to go out and look for authoritative information and incorporate it, or you can build the process to do that. So I think that's a really important point. Don't think of it as just a source of knowledge. It may not even be your primary source of knowledge, but it does know a heck of a lot about languages and how to put together coherent thoughts.
Yes, that's very true. Thank you very much. Are there any further comments or questions from the audience? Before we close, maybe I'll just make a few remarks. It has actually been quite a few years since we started looking at AI specifically in Kyle.
No, please go ahead. I would just like to turn over to Sachin for some closing remarks about the future and what lays ahead in terms of AI development, but please go ahead, Roman.
Yeah, so I just wanted to say that this discussion is not the first one that we had on AI in emergency and disaster management. It's a continuous topic, and we seem to be discovering new and new things every year. Back in 2020, I remember Tom had a paper on the use of very freely available, simple AI tools that can help you go through social media posts. And it used to be used for Twitter quite a lot. There was also a lot of really exciting modeling epidemiological work done to track the social media posts and the progression of COVID-19. Now, unfortunately, since Twitter turned into X, that one software stopped working, but it's still available to work on Facebook. So Sachin, over to you.
You're muted, Sachin, but maybe just some closing remarks and let us know, what do you think as a technical expert in terms of what does the future hold for AI and in terms of technology and adaptation, and where are we going?
Right now, when I am in a small country with 5 million odd people, the ambitions are, in a smaller nation state, is that people feel very threatened with the big tech capabilities. And the good thing is that now some of this technology is getting democratized. So it means that most people can have it. So I see that at the Nordic level and also at the Norwegian level, there's an ambition to build national level infrastructure, which is, something like what you call as the Norwegian model, right? So we are right now writing an application for 160 million Norwegian krona to build a Norwegian language model. Because when these things are built, let's say in US, for example, it has a worldview which is US, right? It doesn't have a worldview which is Norwegian, right? So this is what is happening in Sweden, this is what is happening in Finland, and things like that. And I also see what COVID taught us was that we were not prepared. So there is also an ambition here, at least in University of Oslo, to build a center for preparedness. And I think we have experienced, I think Harald can tell you about rains in Oslo this summer. I think he was suffering from adverse rains. So I think we definitely need to organize resources at a national level and take advantage of these new technologies to be better prepared. So my closing remark is that while technology is there, but still the hard part is curating the data. And that's where experts like you have to join hands, maybe sometimes at the national level and sometimes at the regional level, to provide this as a easy to access service for individual experts so that they can use it in a more contextual manner. That's where my closing remark is. Thank you.
Thank you very much. So thanks to our panelists for joining us today, and also thanks to those of you in the audience that came up to the podium and had some questions. It gave us a very sort of interactive feel, and I really appreciate that. It's very unusual to try and pull these off to where you have that same feeling. So I do appreciate you coming up and having a chat with us on the panel today. as you can see, AI is going to be with us for a long time. So it's really about how we execute, how we adopt, and how we adapt to these new technologies and changes in our environment, especially in terms of informed decision-making, quality of data, and privacy and other concerns, as well as enabling our response and decision-making. So with that, Roman, I think we are done with the panel for today. So we'll turn it back over to you, and thank you very much.
Thank you very much, everyone. So we are running ahead of time, which is excellent, but we also, I think, had a really interesting discussion. There is quite a lot of research that has started popping up on AI, not just in the education and the emergency management space, but all across the world. It is also going to be very important to integrate that into the way that we teach and we practice disciplines that have joined us into this conference. So thank you very much to all the panelists that have joined us from various time zones, and Tom, especially to you, because we know it's really early where you're located. And the audience, thank you very much for attending. We will break for tea and we will reconvene here at 10:30.